Moving on to question 3, what we can see here is that we have a sigma notation where we have a counter k equals 1 to n of 1 over p to the power k minus 1. Since we have a geometric here, since we have powers here, it will become a geometric sequence, right, or geometric series. Series because there's a sigma, so we should be saying geometric series rather than saying geometric sequence. Write down the values of the first 3 terms of the series in terms of p. So 3.1.1, we want term 1, right, we want term 2, and we want term 3. So basically term 1 is 1 divided by k, which is 1 minus 1 is 0, so 1 over p to the power 0 is 1. Term 2 is 1 divided by 2 minus 1, which is 1 over p, and term 3 is basically 1 divided by, so 1 over p squared, because the value of k is 3. So you just keep on moving the counter. So 3.1.2, determine the values of p for which the series is converging. So we have a common ratio, which is 1 over p divided by 1. So 1 over p divided by 1, just 1 over p. So it converges between the interval minus 1 is less than r is less than 1. So the value of r is 1 over p, minus 1 is less than 1 over p is less than 1. Now how are we going to solve this inequality? It's an interesting inequality. Right, so between minus 1, right, so 1 over p needs to be between minus 1 and 1. Therefore the remember the result of 1 over p needs to be between minus 1 and 1. Therefore if we say p is less than minus 1, if we say that p is less than minus 1, example, just take an example of like minus 2, 1 over minus 2 is between minus 1 and 1. Make sure that the inequality is also true. Or the other value of p we can take is p is greater than 1. If you take any positive values of p and take 1 over p, we'll always find that the values of p lies between minus 1 and 1. So these are the two solutions you can get, right? So these are the two solutions. So determine the values of p for which the series is converging. So it converges in between it converges for values of p which is less than minus 1 or value of p which is greater than 1. Right guys, let us look at question number 4. Let's make some space here, right, and shift it up, and let's make more space inside here. So what we are given that the sum of the n terms of a sequence is given by 4 minus 4 into half to the power n. Calculate the first 3 terms. So this is the Sn formula. So Sn is basically 4 minus 4 into half to the power n. Right, so in order to find the Sn formula, right, so we want to calculate the first 3 terms. Looks like a simple question because we can get S1 from here. Right, so what's S1? Substituting n as 1. So 4 minus 4 times half. 4 times half is 2. So 4 minus 2 is 2. Then S2, 4 minus 4 into half squared. Half squared is a quarter. Minus, if you enter this in the calculator, you should get the same answer. 4 times quarter is minus 1. So 4 minus 1 is 3. And S3 is 4 minus, substituting directly inside here, 4 minus 4 into half cubed. You should get an answer of this is half. 4 minus half is 3.5, which is 7 over 2. You should get an answer of 7 over 2. Therefore, what are the first 3 terms? So remember, S1 is just term 1. S2 is equal to term 1 plus term 2. That's what these things are. What does S2 mean? It means the sum of the first 2 terms. So let's write it on this side. Remember, this is just term 1. This here basically means term 1 plus term 2, and this here means term 1 plus term 2 plus term 3. Therefore we have term 1 which is equal to 2. We have term 2. How are we going to find term 2? We need to take S2 minus S1. s2 minus s1, which is 3 minus 2, which is equal to 1. And term 3, we need to take s3 minus s2. s3 is 7 over 2, 3 and a half, minus 3, which is a half. So calculate the first three terms, 2, 1 and a half. Right. Let's look at the next question. That should be your solution. Next question. Okay, next question, we have Euclidean geometry. So what's in Euclidean geometry? We have a proof, right? Straightforward proof. We always get stuff like this. So what we need to write here is mark off a point here, right, on AB and call it G. Mark off a point on AC and call it H, right? And then join GH. So when you're marking off a point on AB, which is the point G, we need to say such that AG is equal to DE. Mark off another point on AC, which is AH is equal to DF. The reason being is because this is a very famous similarity question, similar triangles proof, right? And is very simple because the angles are all given. We're saying angle A is equal to angle D. See, angle A is equal to angle D, right? Let me just mark that off. Yeah, angle A is equal to angle D, angle B is equal to angle E. We also know that angle B and angle E are equal, and the last angle we know that angle C is equal to angle F. Those are given, right? So let us write down what we have marked off here. Let's call it angle G1 and angle H1, right, for later on. So let's say on construction on AB, this is your construction, right? So what's your construction? On AB, mark off point G such that mark of point G such that, let's write such that on AB, mark of point G such that, make this thing smaller, but such that AG is equal to DE, AG is equal to DE, and on AC, mark of point H such that I said AG is equal to D, AH is equal to DF. Now what we need to show is that GH is parallel to BC. So we need to say in triangle AGH, prove congruency in triangle AGH and triangle DEF, right? We can clearly see that we have side, angle, side. So let us write it down. First one, we're going to write, yes, the first one. First reason we're going to write is AG is equal to DE, right? That's by construction, right? Then second one, what we can say is angle A is equal to angle D, right? That's given. And the third one is AH is equal to DF. That's also by construction, right? So we have by construction. Therefore triangle AGH is now congruent to triangle DAF, which is side, angle, side. We can clearly see side, angle, side, right? Now what we can say is that therefore angle G1 is now equal to angle E, right, because of congruent triangles. But remember, angle E is now equal to angle B, right? Because that was given. Therefore, what we can say, remember, angle G1 is equal to angle E, right? Because of congruency. Then what we're saying, but angle E was equal to angle B because that's given. Remember these three things that are given, where I have highlighted those angles that were given. Angle D and angle A are given. Angle E is equal to angle B is also equal to they are given, and angle F is equal to angle C, which is also given, right? So what we can say, therefore what we have is angle G1 now becomes equal to angle G1 now becomes equal to angle B, right? And but these are corresponding angles, right? But these are corresponding angles, right? Therefore what we have, therefore GH now becomes parallel to BC, right? Because of corresponding angles, right? You can either say G1 is equal to angle E, or you can start by saying angle H1 is equal to angle F, and angle F is equal to angle C. Therefore angle C becomes equal to angle H1, right? So if you label your diagram like this, like G1 and H1, you don't need to go and use 3-point notation. Now since we have GH is parallel to BC, we can apply the proportionality theorem now, because remember we already have the parallel line. Let me use another color, right? So we have this parallel lines. So what we can say now is that AG over AB, right? So what we can say now is, or we can say AB over AG, therefore AB over AG is now equal to, remember we can only take prop theorem from here, AB over AG is equal to AC over AH, AC over AH, AC over AH. This is because of prop theorem, proportionality theorem, because GH is parallel to BC, right? GH is parallel to BC, but we have AG is equal to DE and AH is equal to DF from our construction, but AG is equal to DE and AH is equal to DF from construction, is equal to DF from construction, right? Therefore AB over AG, we can say this implies, right? Concluding here, so this implies AB over AG is now AB over, not AG, AB over DE, AB over DE is now equal to AC over DF. So did we prove it? AB over DE equals AC over DF. AB over DE equals AC over DF. Perfect, right? And that's how we should get our 7 marks. Next question, guys. Make some space here. Right, so we have this proportionality theorem, right? So should be dealing with proportionality theorem. They should have gave this question first and then this one here with the similar triangle, but anyways, see, because we're jumping from similar triangles to proportionality theorem now. So let's see what we have in triangle ABC, the big triangle. We've got HG, which is parallel to AC, and we got ED is parallel to BC. HG intersects K, AD over DC is 3 over 2. So remember, what we are looking for is a triangle with a parallel line, right? So we're looking for a triangle which has a parallel line inside. So there are some hidden triangles. See, like HK, can you see HK and ADC? AED is like a hidden triangle in proportionality theorem, right? Are there any other hidden ones? So we can see HBG as well. See HBG, and we got ABC with ED parallel to BG, and for the small one here, so I can see like 4 proportionality theorem triangles that I can find inside here in this diagram. Anyways, let us answer this question. Now let us fill in all the information that we have. What we have here is AD to DC is 3:2, so AD to DC is 3:2, so we say 3x is to 2x. You can use any other alphabets if you want, like A, B, C, D, H, K, L, M, N, right? Just avoid using alphabet that looks like numbers, right? Otherwise you will get confused. And now next one, what we have is BG is equal to 2GC. So in other words, BG over GC is 2:1, so GC should be Y, right? And BG should be 2Y, 2 times Y, which is 2Y, right? Now we want to find the length of AE. If we want to find the value of AE, in other words, we want the actual length, so we should have some distance here. So what we have here is AB is equal to 15. What we have here is AB is equal to 15. Yep. So let's say this is 15 units, right? Now since AB is 15, we will take in triangle ABC, so 4.2.1. so in triangle ABC, like I like to write down the triangle first where I'm applying the prop theorem. So in triangle ABC, I'm looking at ED parallel to BC, so we should be taking that over AC, remember, because AE is my unknown. So I can say AE over AB is equal to, so remember, AE over AB is equal to AD over AC, AD over AC. And the reason over here is prop theorem, proportionality theorem, right? Reason here is proportionality theorem because ED is parallel to BC. Right, now AE is unknown. I can just take the AB and cross multiply, so AE is now equal to AD is 3 over 5, so you can say 3 over 5 into AB, which is 15, and we should get the answer, which is the 5 and the 15 cancels out. You can see 1 time and 3 times, 3 times 3, which is 9. So AE should be 9 units. Now if AE is 9 units, let's use a different color here. Okay, too many colors. Let's say so that's 9 units. AE, let's draw something like that. That's 9 units, right? And from here EB should be 6 then, right? Because 9 plus 6, and now we can take out the 15 there, right? Perfect. 4.2.2 4.2.2 in 4.2.2 we want to go and find AH, right? So AH, as I've said, let's see how we're going to calculate AH. We have AE to be 9. How will we calculate AH? Maybe we need to look at this triangle over here on this side. So in triangle ABC again, in triangle ABC, I'm looking at this side, which is parallel, which is HG is parallel to AC. Let's try to work with the Y's. So we want to find AH over, we can say AH over AB. So you can say AH over AB is equal to, what we are saying, AH over AB is equal to, said AH, so we should go CG should go CG over CB. That's because we have prop theorem here as well. Prop theorem, in other words proportionality theorem, with HG being parallel to AC. Right, and if you solve this for AH, remember we're taking the AB across. AB is already 15, so CG over CB, CG is Y, so CG is Y over 3Y, so in other words 1/3, right? So we have 1/3 into 15, so 15 divided by 3, which is 5 units. Let's write units here as well. Right, so we have 5 units for AH. Now obviously if we have AH to be 5 units, if AH is 5 units, then we're left with HE, which is 4 units. Right, so those two questions are sorted out. Let's look at the next two questions. Let's see. Now they are asking us for GK to KH, GK over KH. What is GK over KH? GK over K. So remember those 4 prop theorem triangles I was talking about. There's it here. Looking at this line, which is parallel to this line. So GK is to KH. So I'm going to write here 4.2.3. So we're choosing a triangle in triangle HBG. Right, so we're saying GK to KH is equal to, so what you're saying, GK to KH is equal to BE to EH. BE is to EH. And that's also proportionality theorem, because EK is parallel to BG, because EK is parallel to BG. We have EK which is parallel to BG. Now what is BE is to EH? BE to EH, BE is 6, EH is 4, so we have 6 over 4, which is 3 is to 2. Right, so I hope you understand, guys. Don't forget to leave comments if you don't understand anything. Right, now next one, we want to find the ratio of areas. Now when we're finding the ratio of areas, let me just take this triangle again. I just want to crop it out quickly, right, so we can actually see that triangle. Let's see. So I just want the triangle from there. Alright, so let's crop this triangle out, and because the previous triangle I've written too much of stuff on that. Alright, so let's see. On this triangle, we want the area of triangle HEK. So this area of the small triangle here to the area of the HBG. So it's the same triangle. It's a small triangle with a big triangle, right? The ratio of the areas. So what we can say is that since we have a common angle here, we can say half for the top triangle, half HE times, so we're using the sine rule, HE times HK, right? So when we have common angle, we use the sine rule, half AB sine C, right? So sine of angle H. Right, so for this triangle here. And the next one is half, what is this? This is HB times HG, right? Sine of angle H. You can call it angle H1 because there's two angles H here, right? So what we can clearly see that sine H and sine H cancel out, the halves cancel out. all we are left with is HE. What was the distance HE? The distance HE was 4 and the distance HB was 10. So 4 and 10. So we have 4 over and we have 10 down. Remember HB is 10. So remember this was 4 and this was 6. Right. Next one, HK. What is HK? Remember HK is like 2y. You can use another alphabet, maybe 2L is to 3L, because I'm taking it from here. HK is 2 and GK is 3. GK is 3. Right, so 3L. 2L is to 3L. So what is HK? 2L. And what is HG? Which is 5L. Now what you can see is that the L's also cancels out. So, and we can also, obviously we can also cancel this out, or we can just simplify it. 4 times 2 is 8. 8 divided by 50. 8 out of 50, which is 4 out of 25. Right, that should be your solution. 4 divided by 25. So what is the area of triangle HEK divided by the area of triangle HBG? 4 out of 25. Let's see, 4 times 2 is 8. 8 over 50. Just divide this by 2, so that's 4. Divide this by 2, that's 25. Yeah, that's correct. Now moving on to the next question, which is question number 5. Let's see how we're going to solve this. Right, very important, we have a circle geometry, right, together with triangles, so it should be a similarity question. Anyways, let us read the story. PQ is the diameter of the circle, so PQ is the diameter of the circle. SP is a tangent. Now since we have a diameter and we have a tangent, remember this is tangent perpendicular to radius, so we have a 90 degree there. QT, so we have line QT, it intersects the circle at W with T on the line SP. W is here with the line SP right there. QS intersects the circle at R, so we have QS. Why did they give us that information? QS intersects the circle at R. Okay, that's okay, that's fine. And angle P1 is equal to X. So if angle P1 is equal to X, we have angle P2. Now remember, this is the diameter of the circle. We forgot to put this 90 degree there as well at angle R. Now since this is the diameter of the circle, we can say that this is 90 degrees minus X. Since we already have X there, we can just put this as 90 minus X. We don't need to put that. So since this is 90 minus X, angle between the tangent and a chord is equal to the angle in the alternate segment. So let's see, there's a tangent, there's a chord here, and directly opposite, that should also be 90 degrees minus X. But we can see it from angles of triangles, sum of angles of triangles. Yeah, we can also work this out because we have X and we have 90, and alright, so automatically that, alright, so let's just put the 90 degrees there. Now let's read the first question. 5.1. 5.1 says, why is PRQ equal to 90 degrees? Why is angle PRQ is equal to 90 degrees? So why? The reason is angles in a semicircle. That's the reason why it is 90. We filled it in. Prove that angle S is equal to X. How is angle S equal to X? Very simple, right? We've got angle P2 5.2, right? So we need to say PS is perpendicular to PQ. PS is perpendicular to PQ. Diameter perpendicular to tangent, right? And we can say therefore angle P2 is now equal to angle Q1. Let's use 3-point notation in this case, or you can say angle Q1 plus angle Q2, which is equal to 90 degrees minus X. This is because of tan chord theorem. So tan chord theorem, we have this to be 90 degrees minus x, because this is also 90 minus x, right? Now you can see the tan chord theorem, which is right here. There's your tangent and your chord. See, directly opposite the chord is that angle q1 and q2. So it's a little bit too thick, right? So let's make it like this: 90 degrees minus x, and this angle here is also 90 degrees minus x, right? Now remember, you got a 90 degrees minus x here, you've got a 90 degrees here, so obviously this angle has to be x. Look at the bigger picture, right? Like your trig diagram, if you have x there, you need to have 90 minus x there, and that's 90 already. So angle S is now equal to x. Why? Because sum of angles of triangle, sum of angles of triangle PQS, and that's the reason why angle S is equal to x, right? So we have enough information. Let me just take out this 90 minus x from here. You know that because we use tan chord, right? So let's just search 90 minus x. Now what you can see here is that this is remember, when you put the 90 here, it means that this side is also 90, because this is a straight line. They told us it's a straight line somewhere around here. Right, now you can see some similar triangles happening here. You can see PSR, and you can see PQS. Those are similar triangles because you got 90 degrees, 90 minus x, and x, right? So keep that in mind. We got a common angle. We got the angle 90 minus x, and we have a 90 minus x. So remember, just keep that in mind. So those are some of the similar triangles. We even have a similar triangle on this side. This is also similar to the bigger triangle. So we have 3 similar triangles. Right, so let's see, what did they ask us for? To prove that SRW2 is a cyclic quadrilateral. SRWT, we want to prove that SRWT is a cyclic quadrilateral. So SRWT is a cyclic quadrilateral. So we need to prove that SRWT, where's SRWT is a cyclic quad. So we can find angle. Which angle can we find? That's the problem. Let's see, which angle can we find? SRWT, how are we going to find that? SRWT, so either by saying, oh okay, so this 90 degrees is a bit, it's confusing me there, right? So let's take that out. So remember, angle, you need to prove that angle T1 is equal to angle R3, or we can go across here, yeah, SRW. In other words, we need to prove that angle W2, else we prove that angle W2 is equal to X, prove that is equal to angle S there. SRWT, how is it a cyclic quadrilateral? Can we get angles in, so I didn't look at this circle properly, so let's look at angles in same segments and stuff. So that's 90, no, you don't have that angles in same segments. If you try WR, we're going towards angle Q1, no, we're not getting anything there. Okay, so what's the other approach? What else can we use here? So we do have 90 degrees minus x there. We have 90 degrees minus x here. Remember, what did they tell us about any information about angle Q1 and angle Q2? They didn't tell us that it's tangent to the circle PQT intersects WT on the line SPQS intersects interior no, this is not an exterior angles of triangle, so exterior angles of a cyclic quad. So what we want to prove is this one here. Let me just draw a circle around this. So alright, so that's the cyclic quad that we're trying to show. S R W T. Yes, S R W T. So that is X. Let's take that out. Right. This is clearly angle R1 is clearly not an exterior angle. Sorry, is clearly not an exterior angle because your line ends up being there, right? So that's the cyclic quad that we want to prove. So in order to prove that something is a cyclic quad, we need to prove that the exterior angle is equal to the interior opposite angle, or opposite angles of cyclic quad are supplementary. Obviously we can't find angles in same segments here. That's the only problem. Right, so how can we solve this? That's 90 minus x. That was 90 minus x there. That was 90 minus x here. Right, so perfect, guys. I'm looking at this triangle over here. Look at this triangle PSR, because that angle P2 is given. So what is angle P in triangle PSR? Right, remember this is also 90, so we can actually find angle R3. So in triangle PSR 5.3. So let's see, sum of angles of triangle PSR. So we can find angle R2 plus angle R3. Remember that is equal to 90 degrees because of supplementary adjacent angles. So angles on straight line. Right, that's angles on straight line. Now what we can say is that angle, oh, that was 90 minus x. Oh, okay, that's not going to help us. That's angles on a straight line. So how else can we solve this problem? Prove that SRWT is a cyclic. I'm just looking for some clues here, guys. Let's look for some clues. And put that back there. 90 degrees minus x. I was thinking, okay, that's, oh, why did I take out the previous reason? Let's put the previous reason back in. What we were saying is, yeah, the reason why we said that, yeah, we did say that that is 90 degrees. I was hoping to find angle R3. Yes, so how can we find angle R3? Angle R3 needs to be equal to angle T1. Needs to be equal to angle T1. Angle R3 needs to be equal to angle T1. Okay, see a pattern here. Let's see. Alright, let's take this out because we already have this. Right, so quite challenging, but anyways, let's look at chord QR. So you can see this angle W2 is basically equal to x. Why? Because angles in same segment. So angle W2 is equal to angle P1. So angle W2 is equal to angle P1, which is equal to x. Angles in same segments. Remember, that's what we're looking for, exterior. Now we can see we got an exterior angles of cyclic quad. Exterior angles is equal to interior opposite angle, and we can say therefore angle W2 is equal to angle S, which is equal to x, and therefore TSRW or SRWT SRWT is a cyclic quad. The reason is because converse exterior angles of cyclic quad. Converse exterior angles of cyclic quad. Now prove that QWR. Prove that QW. I just want to copy this and just look at. Oh yeah. So remember we had 90 minus x here as well. 90 degrees minus x. Let's see. QWR. QWR. So we have QWR is now similar to QST. QWR and QST. It's a very small triangle. So QWR and QST. So we can say angle Q1 is common, right? QWR. So QWR and QST. So this small triangle, so it's basically this triangle here to the entire big WR. We can say angle Q1 is common. So in triangle QWR and triangle QST, I mean, this one took us long, couldn't find that, kind of hidden that information. Alright, so QWR and QST. Let's underline this. And triangle QST. Number one, you say angle Q1 is a common angle. Right. Angle Q1 is common to both. Then we got angle W2 is equal to angle S. Second one, angle W2 is equal to angle S, which is equal to X. Proven in question 5.3. We proved this in question 5.3. And the third one, I would like to write this in 3-point notation. So the third one is angle R1 plus angle R2. So WRQ. So angle WRQ is now equal to, what are you saying? WRQ is now equal to STQ. And that's sum of interior angles of triangles. Right, so basically the third angle of the triangle, sum of interior angles of triangles. In other words, angle T2 is equal to angle R1 plus angle R2. You could have written that instead of this 3-point notation, but try to get used to both. Therefore, triangle QWR is now similar to triangle, what we said, QWR is now similar to triangle QST. Let's write it neater. QST, angle. Alright, perfect guys. Nice question. It's just that 5.3 we couldn't see this chord here. But remember, I did tell you that we need to prove that this angle is equal to X, exterior angles of cyclic quad. Converse exterior angles of cyclic quad, or prove that the opposite angles are supplementary. Alright, so that was the only problem. Anyways, let's look at the next question. So what do we have here? We have some information saying if QW is equal to 5. Right, so if QW is equal to 5, we need to enter all this information on this diagram. I think I was simplifying the diagram. No, not this one here. Let's try to just pull out that piece of the diagram and put it there, because we have a bit too much of information and all those highlighting and filling in angles. Right, so let's work with the new diagram. Yeah, So when you are marking off your diagram, make sure you mark them off in pencil. So I just want to put this diagram in the side because that's the information that we have so far. Right, so we know that this angle is equal to x, and that angle was equal to x. Now what they're telling us, QW is 5. So QW is 5. So this length over here, which is kind of dealing with this triangle over here. So let me write triangle QWR is similar to triangle. That will be your reason if you're taking some ratios. QST. So we are taking QW, right? And we're saying TW is equal to 1. Where's TW? QW and TW. So TW is 1 and QW is 5. So why can't we just say QT rather, not QW? Let's take out QW from here. You can just say QT. Remember, QT is just 6 because we don't have TW in our similar triangle. Can you see? Don't have TW here. So but we do have QT. So QT is 6. So the first and the last. So obviously if you say QT over QR, that's what you need to say. What we have, QR, which is 4. QR does fall on that basic line on this triangle over here. QR, which is 4. Let's fill in these information. 4, this was 5 and 1, right? And then we've got WR, which is 2. WR which is 2, which is good because most of the information in this triangle is given. So we got WR, which is 2. So now we have our ratios sorted out. So let me just take from the first triangle to the second triangle and move on. So we want ST. So you can see WR over ST. Let's write there, or let's write ST over WR. ST over WR. So ST over WR is now equal to QT. QT over QR. Do we have QR? QR, yes we do. So basically have all these we basically have all these information over here. I just move the trig lower down. So remember, we want to find TS. Now ST is unknown, right? So ST is equal to QT. QT is 6, QR is 4, and remember I took the WR over, so I'm going to multiply WR times QT over QR. So WR is towards the end, so I took that over. Now basically cross multiply, so taking that over. WR is 2. They told us WR is 2. Did they tell us WR is 2? Yes, it's there. And 6 times 2 is 12 divided by 4, which is 3 centimeters. So ST is 3 centimeters. So that was the first part. And the second part, and just add some space inside here. 5.5.2. 5.5.2. Right. That should be 5.5.1. 5.5.1. Right. Now let's see, 5.5.2, we want to calculate what is SR. SR is right here. Now remember, SR doesn't make any triangle, so we need to find QS. So try to find QS over QR. Let's try to find, so in triangle, so we're going to put down triangle QWR is now similar to triangle QST. So let's try to find QS. We just found ST now. ST was 3 centimeters. So let's see, we can use we want to find SR, so we can say QS over QW. So QW, do we have QW? We do have QW. And WR over ST. WR over ST. Yes, we can use both. So let's write it down. Now we're going to say RS just as RS. So when you're writing down QS, so let's write QW. Wait, our unknown is QS. Yes, so we need two different ratios. So remember, unknown is QS, we given all that, so taking these two ratios here. So we're taking QS over QW first. QS over QW, QS over QW is equal to ST over WR. So QS over QW equals ST over WR. We took this, started with this first, then we went on to the second one. So we can fill in all the information again. What is QS? QS is 4. Very important to look at the triangle. Don't just look at this, look at the triangles as well, because sometimes they break up the line. So basically QS is 4 plus RS, and that's how you can have 4 plus SR. So 4 plus SR over, what is QW? QW we said it was 5, that was given. ST we just found, which is 3, and WR is 2. Right, so if we cross multiply and subtract 4, you should get the answer. Therefore 3 over 2 times 5 minus 4. Therefore SR is equal to 3 over 2. 3 over 2 times 5 minus the 4. That should give you 15 over 2. 15 over 2 minus 4. So let's just say 15 over 2. Just put it in the calculator. 1.5 times 5 minus the 4. Right. So we're getting 7 over 2. Right. So 15 over 2 minus, so 7 over 2. Yeah, we could have just used LCD to find that. Right, so 7 over 2 centimeters. That's my distance, SR. I hope you understand, guys. Don't forget to leave comments. Right, next question. So we're on to trigonometry now, guys. Right, so obviously I can solve this paper much faster. It's just that you guys need the detailed explanation. That's the reason why we are solving this paper in detail. So what we can see is cos of 20 degrees is equal to P and sine of 14 degrees is equal to Q. So when we have when we have problems like this, we draw two separate triangles. So 6.1.1. So this is a diagram question, right? So let's draw two separate triangles. So this is my first triangle here. Right, I like to draw a triangle that looks like as if it's in the first quadrant. Right, so not really putting quadrants there because there is no second information. So cos of 20 degrees is equal to P. There's 20 here, right? And P adjacent hypotenuse, that will become square root of 1 minus P squared. Obviously the top angle is 70 degrees. So these are all the stuff that I've solved. No, not the 20 degrees. I've solved the 70 degrees, right? And I've solved that. Now if you have to write down the next triangle, let's draw the next triangle. So even though they're not, I'm just looking at the question, sine of 20, they're asking for sine of 20, so you need it from the triangle there, right? So sorry about that. Let's see, draw the triangle. Let's draw the triangle. Next triangle we want to draw is the talking about sine 14. So 14 degrees here, 14 is Q over 1, and that is square root of 1 minus Q squared, and the top angle should be 76 because that's 90 minus, right? So 1 minus Q squared and 76, right? So those are your two triangles. Let us solve. What is sine of 20? 6.1.1. So that's basically these two triangles, part of your answer. It's better to draw both the triangles. So sine of 20 degrees we'll take from the first triangle. Sine of 20 degrees is equal to opposite over hypotenuse, so katoa, so 1 minus P squared. 6.1.2. see, we want cos of 6 degrees. Hey, wait a minute, how do we get cos of 6? It's a nice question. Right, so cos of 6 we can either use angles of triangles. You can see adding, subtracting, not getting 50. We're getting 50 here, adding and subtracting. Right, so and we're getting 90 and 50. If we add and subtract here, we're not getting any way. So to find cos of 6, we need to look at both the triangles, use angles from both the triangles. So I can see cos of 6 degrees. I can make 6 degrees by saying cos of 20 degrees minus 14 degrees. So 20 degrees is from the first triangle, 14 degrees is from the second triangle. Now let us use the expansion for cos. Expansion for cos is cos 20 cos 14 plus opposite sign sine 20 sine 14 degrees. Now let's take all the information from both the triangles. Right, so let's align this equal to signs. Right, so what is cos of 20? Cos of 20 is adjacent of hypotenuse, which is p over 1. So don't write over 1. Everything is over 1. So as p over 1, don't write it out. Right, so just write p. I'm just showing it for the first part. Cos of 14 is adjacent of hypotenuse, so square root of 1 minus q squared. Okay, plus sine 20 is opposite over hypotenuse, which is square root of 1 minus p squared, and sine 14 is from here, opposite of hypotenuse, which is q. So these two things can't be simplified, so we just say p into square root of 1 minus q squared, there's no like terms, plus q into square root of 1 minus p squared. Right, q into square root of 1 minus p squared, and we can't do much here, leave the answer just like that. Yeah, that should be, because they said must write the following in terms of p, q, o, p and q. Yeah, write the following in terms of p, q, o, p and q. So anything, write it in terms of p and q or p, o, q. Right, so next question, let's see what we have here. Right, so we got some simplification going on here. Right, so half sine 2x. Right, so interesting question. We just have to keep on drawing square roots. That's right, so we don't have an option for sine 2x, which is straightforward. Remember, sine 2x is just a double angle, so that's straightforward. So we got square root of half times 2 sine x cos x. That's the first thing you should do. Right, expand the sign, and now you can see half times 2 cancels out, so straight away we can see some cancellation there. Half times 2 is 1. Tan of 540 degrees plus x. If we remove 360 from here, so let me write this out. Tan of 540 degrees plus x, right, you can do the working in the side, which is equal to tan. Right, so if you remove the 360 from here, you'll be left with 180 plus x. So in other words, we're taking out a revolution, take out 360. Right, so we are left with the third quadrant, which is just tan x. So you can just write down. And what is tan x? Sine x over cos x. So we need to show all this working. That's why we're not going to put 100 different square roots here. Right, so just write tan. Remember, this is tan x, so that's sine over cos. So we are going to get marks here, so we need to get a mark there and a mark there. Right, so what we're going to say is sine x over cos x. That's what it is. My x looks like a times. Let's neaten it up a bit. So sine x and cos x times, let's see what we have here. We got 1 over cos squared minus tan squared. So the second one, we got 1 over cos squared x. I want to simplify that, minus tan squared x, which is sine squared x over cos squared x. That's what tan squared is. If I simplify this, I've got cos squared x in the denominator, same LCD, and 1 minus sine squared here. You see, if you keep on writing everything under the square root, you're going to end up writing so many different square roots. So 1 minus sine squared is cos squared x over cos squared x, right, which is just basically equal to 1. So just times 1 here. Right, and now since we are working with everything under the square root, now remember the sine x will also has to cancel out with the sine x here. Now guys, you'll also get marks for doing all these things on this side. Right, it's 6 marks, so 2 marks there, 2 marks there, and you should be able to get some marks for cancellation. It's just that I didn't do all this inside the square root because I just have to keep on drawing so many different types of square roots. So I did this is all part of working for this example. Now we can see the sin x cancel out. Now cos divided by 1 over cos is cos times cos over 1, so which is basically square root of cos squared x, which is just equal to cos x. So that's my final answer, which is cos x. I hope you understand, guys. And all this is also part of your solution. So now let us look at question 8, question number 7. Right, so we got cos 4x, which is equal to 8 cos squared x minus 8 cos squared x plus 1. So basically we want to put cos in terms of cos. Right, so we want to put the cos in terms of cos. How are we going to do this? So we got cos 4x, so let's say left hand side is equal to cos 4x. So let's multiply by 2 times 2x. Right, cos 4x is 2 times 2x. Now cos double angle, there's 3 of them, but we want everything in terms of cos, so we'll say this is just basically 2 into cos squared 2x minus 1, because remember cos 2 times angle is 2 cos squared angle minus 2 cos squared angle minus 1. So cos 2, yeah, so 2 cos squared angle minus 1. So what we have here is, now we got a double angle again inside here, so you got 2. So what will you be doing there? You going to be squaring inside here. So what is cos squared? Right, so remember this was your angle like this, 2 times angle, so 2 cos squared angle minus 1. There's the angle 2x. Now what is cos 2x? Cos 2x is 2 cos squared x minus 1, so you can just write down 2 cos squared x minus 1. And now if you open up everything, you should get that answer, which is 2. Remember we're squaring a binomial here, so 4 cos 4x, middle term is product of these two and double them up, so minus 4 cos squared x, and square this, plus 1 minus 1. So what we have, 2 times 4, which is 8 cos 4x minus 8 cos squared x. We got plus 2 minus 1 ends up being plus 1. I hope you understand, guys, and that is now equal to RHS. So it was just double angle, right? Twice double angle substitution. Next one, since they said hence or otherwise, right? Hence or otherwise, without the use of a calculator. When they say without the use of a calculator, it basically means you could be working with a special angle. So what we have is 16 cos 4. So what we can do here is, look at this, we got 8 cos 4 minus 8, but now we got everything over here to be 16. So we're going to divide both sides by 2. So we're going to say 8 cos 4x minus 8 cos squared x plus 1 is equal to a half, because we divided both sides by 2. And this here is just basically equal to cos 4x, which is equal to half. Now we want the general solution, so we're going to write down reference angle is equal to cos inverse half, which is 60 degrees. Remember cos of 60 is half. So what is your reference angle? So where is cos positive? So in the cos diagram, cos is positive in the first quadrant and in the fourth quadrant. So we're going to say 2x, we're going to say 4x is equal to, so we're going to say 4x is equal to 60 degrees plus k360. Don't forget to write k is an element of z. We can only choose integer values. Therefore x is equal to 15 degrees plus k, we're dividing this by 4, so 90 degrees. Or what about the second general solution? Or 4x, fourth quadrant solution, is equal to 360 minus 60, which is 300 plus k 360. So therefore x is equal to, yes, so 300 divided by 4 should get 75 degrees plus k 90. Right, so these are the two general solutions you should end up with. I hope you're understanding, guys. Next question. write down the minimum value of, what's the minimum value of this expression. Now remember that expression is already equal to, remember if I take out 2 as a common factor here, I'm left with 2 into cos 4x. Now how I got this cos 4x? Because remember this entire expression over here, this entire expression, that first identity we prove, if I multiply both sides by 2, I am going to get 2 cos 4x is equal to 16, then a 16 here and a 2 there. So that's what I have 16, 16 and a 2 there. So that is just cos. So what do they want here? They want the minimum value. Now remember this cos 4x is like a trig graph. You need to remember this as a trig graph. So if you remember this as a trig graph, the period is 360 divided by 4, and the minimum and maximum value is, maximum value, the amplitude depends on the amplitude. So the number in the front is 2, so the maximum value is 2 and the minimum value is minus 2. Minimum value is equal to minus 2. So we write down the minimum value of this expression. Right, so minus 2 is your answer. Next question. I'll make some space here. Right, so they are asking us for 2 sine squared 22.5 degrees minus 1. Now what is 2 sine squared minus 1? So we know that cos 2 times angle is 1 minus 2 sine squared a. So basically this is the reverse, so it has to be negative into 1 minus 2 sine squared 22.5 degrees, right? So that's what we're thinking about, and that should be right. So that is a double angle there. Now the 4 sine, you can see 4 sine 22.5. Now remember, what is sine 2 times angle? Is 2 sine angle cos of the angle, 2 sine of the angle cos of the angle. So now you see you got a 4 there, right? So since you got a 4 there, you can break up the 4 into 2 times 2 sine 22.5 times cos 22.5 degrees. Now what we have, we can group these up. See there, that one and that one. That's cos double angle, double the angle here, 22.5. So negative cos 45 degrees divided by 2 times all of this sine 45 degrees. But remember, cos of 45 and sine 45, those are special angles, but we can also use not necessarily special angles. We can also cancel out the cos. You can change the cos 45 into sine 45 because of co-ratios, but let's just substitute special angle. But they said without the use of a calculator, so we should be using 1 over root 2 into 2 times 1 over root 2, right? And you should be able to cancel them out like this and get an answer of minus half. Or alternative solution, you could have said this is just equal to negative sine 45 over 2 sine 45 degrees. So I converted the cos 45 into sine 45 and cancel those out. We should get an answer of minus half. So basically I'm just simplifying, minus half. This is an alternative solution continuing from here. So in both cases we can see we're getting minus half. Right, so I think most of the guys, they probably did this, but if you did the second method is also correct. Right, so let me just, okay, let's just keep it there. Right, question 8 on trig graphs. Right, we want to sketch this graph here. Right, so sketching this graph, I'm just going to use a calculator and sketch this for you, right? But obviously there are easier techniques of sketching. Right, so we need to sketch the graph, and then after, okay, you can just sketch the graph, and then after that we have one more question, which is finding g of x greater than f of x. So let's just put it here, 8.1, 8.2, right? So that was 8.1 and 8.2. So we need to sketch the graph and then find where f of x, g of x divided by f of x is greater than or equal to 1. So let us sketch the graph from minus 90 to 180, sine 2x. Sine 2x, so I'm going to use my calculator, put it into mode function, go to table, which is 7, f of x, which is sine 2x, how is it, x alpha x close bracket press equal, g of x is 2 cos alpha x close bracket. I want to start at minus 90 degrees. Right guys, if you don't have this fancy calculators, you just have to keep on substituting values like minus 60, minus 90, minus 30 into each one, getting the value. Right, so minus 90, and we're ending at 180 degrees, and you can clearly see the steps of 30 degrees there, right? So steps of 30 degrees, famous steps are 30 and 60 and 45, 30, 45, 60. So we can see for minus 90 we're getting a value of 0. When the value is minus 90 we're getting a value of 0. So let me sketch the graph of f in blue. So minus 90 is 0. Let's carry on. Minus 60 is negative 0.866. Minus 60 is negative 0.86, and minus 30 is exactly the same value. So it's basically this graph is coming down, minus 0.866. So minus 0.866 is here and there. Now whenever you get something like this, you go in between and get that value there. In other words, the 45 degrees. So you'll be joining these three dots here, and then for this point you should get a 0 next value. I can see what the graph looks like. So minus, yeah, so you're getting a 0 there. So obviously you can't make a table here, you can't join those two like this, so you have to join it up like this and go up. And next graph, you can see how quickly this graph is being drawn. Look at 30 degrees, 0.866. So 30 degrees, you'll get the same scenario here now, so you put something in between there, right? And next one, at 60, 0. Yeah, so at 90 we got 0, correct. And then next value at 120 we're getting negative 0.866, 150 same, and then 0 again. That one, so we need to go in between, basically 135. And at 180 it is 0 again. Yes, so let's sketch this graph here first. Yeah, I'd rather sketch this graph and then go back to sketching the next one. Alright, so let me try to sketch it neat. And I don't want my pen to slip. Right. So guys, obviously you guys have more control, right? So I'm trying to write on my tablet here, and alright, so trying to be as accurate as possible. Right, that's the best I can do. I just got messed up a bit there. Anyways, now let's look at the next graph. Right, so the next graph is a g of x graph. I'll draw that in red for you. Right, so at yeah, let's choose a red color. When the value is 0, the value is 2. 2 is right there. When it is 0, it is 2. Next one, 1.73. 1.73 we need to estimate. That's 1.5, 1.73, somewhere around there. Right, at minus 30. Oh, at minus 30 we're getting a value of 1, which is great. At 90 we're getting a value of 0. At minus 30, at 0, what happened to 0? Okay, supposed to go straight up. Right, so okay, at minus 90 we had 0. Just want to see if we drew this graph correctly. What's the period of this graph? The period of this graph is 90, so every 90 degrees we should be getting one wave here. Sine graph starts from 0, 90 degrees, right? So 91 wave, and then okay, this graph is correct. Just looking at the cos graph, 2 cos x, so the graph needs to start at 2 and come down. Right, so 2 cos of 60, we know uh, cos of 0 is right, so it has to go through there. Let's go back up. At minus 90 the value is 0, as a value is 0 at minus 90. Perfect. At minus 60 the value is 1. Alright, at minus 90, so it's kind of going up, so 1.73 should be there. Yeah, so 1.73. So we can see the graph is going upwards like this, right? And then looking for a drop like this, and it should go through there, and it should go through there. Yeah, so it should be symmetrical. So that point there, that point is there, and that, yeah, should be symmetrical. Right, so as that point is getting messed up. Alright, so should go through that point 60. We'll just double check all these points here now coming. Alright, so let's double check these points again. So if you get the same thing, at 0 we're getting 2, 1.73, perfect. At 30 degrees we got 1.73. At 60 degrees we got 1, and at 90 degrees we got 0, and then 120 we're getting minus 1. Right, so this graph here I think is going to come down like this, minus 1, right? And then at 150 we should get negative 1.732, negative 1.732. 150 is negative 1.732. What was this value here? 0.866. 150 is negative 1.732. It should be here. Yes. And at 180 it should be minus 2. Correct. So that's the graph that we've got. Yeah, the cost graph should be coming like this. Yeah, should be changing over there. Yeah, I just little messed up here because of my pen, so I just try to neaten it up here as well. Right. Just trying to neaten this up. I don't know why it's bending up over here. Yeah, that should be better. Right, so that's going through at 120. Right, now the second graph that I drew was G, and this is a graph of G, as a graph of F, as a graph of F, right? And that's a graph of F. So the second question that we want to find out is, use a graph to determine where g of x is greater than equal to g of x over f of x is greater than equal to 1. So g of x over f of x is greater than equal to 1. If you multiply both sides by f of x, remember f of x is not equal to 0. We have a restriction. F of x cannot be equal to 0 for the denominator. So what we can say is multiply both sides by f of x. So we got g of x is greater than equal to f of x. But remember there's a restriction here. So where is the g graph above the f graph? So where is the g graph above the f graph? So looking for the g graph which is above the f graph. Remember at minus 90 we can't include minus 90 because we'll be dividing by 0 there. So we can't include minus 90. So x is an element. Okay, let's write it in this notation. Minus 90 degrees is less than yeah, in inequality notation, right? So minus 90 is less than x, is less than from minus 90 to 90 degrees. Where's the graph of g above the graph of f. G of x is 2 cos x, and this is sine 2x from minus 90 to 180. Use the graphs to determine. So basically they should have specified an interval here, but anyways we need to look at the entire interval. So from minus 90 to 90, not including we can't get from minus 90 to, but remember we got a problem over here at 0, because sine of 0 will be 0, so you can't say from minus 90 to 90. It has to be minus 90 to 0, so it should be less than 0 degrees, or 0 degrees less than x is less than 90 degrees. Yeah, so you can't include any points, any x-intercepts of f, because at the x-intercepts the y value will be equal. We don't want that. That's one way to write out the solution, or you can write it out like this. X is an element from minus 90 to 90 degree, but x is not equal to 0 degrees. Very important, you have to say x is not equal to 0. So it's not equal to minus 90 or 90, and it's not equal to, but x is not equal to 0. But I prefer this method here, just write this. Okay guys, so this ends the paper. I hope you understand. If you have not subscribed to my YouTube channel, please do subscribe, and all the best guys. Don't forget to comment in the comment section below. Thank you.